There we go. So what I have in here, I have gas in contact with a hot source, which is in this case combination of the fuel coming from the I'm going to turn it off. There is not enough energy, not enough heat coming from the because I have alcohol in there, rubbing alcohol at 91% alcohol, and I think it's diluted. So that heat is being transferred into this at constant temperature, and this one is actually, the second cylinder is also at constant temperature. And what happened in this case is there is an exchange of heat in here at constant volume, both during the compression and the decompression stages. So this is a 4-stroke engine. This is a Stirling engine. So basically you have an isothermal and an isothermal at lower temperature. So this is TC, this is TH, and you also have two processes at constant volume, in which case there is no exchange of work at that point. There is no expansion of compression, I mean in terms of the volume, but there is definitely change in pressure and temperature during those stages. So that's basically the Stirling engine. Let me see if I can get the second engine also going. That too needs to be kicked in to get it started too. I have the alcohol, but as I was saying, I don't think the concentration of the alcohol is high enough to get this thing going. Let me see if I can. It's really hard with this. I may have to transfer that thing there, but it's hot. Okay. Okay, there we go. That too, it's the same principle. You have actually a cylinder in here in contact with the hot source, and you have the second cylinder in here is going up and down actually with the cold source from temperature, and there is an exchange in here of energy at constant volume. So again, it's a 4-stroke engine. It has a isothermal and two isothermals, I'm sorry, one at T hot and one at TC, and also you have two isochoric processes. Okay, so this is a demonstration. Obviously, because this thing went out, that's why it stopped, and I couldn't get that lit. But this one, the alcohol is still going, and it's providing enough heat to counterbalance the other heat in here at constant constant temperature, I'm sorry, TC. So this is your TC, this is your TH, except now in here, like I said, there is an exchange of energy at that point. Namely, there is no work during that stage, but there is heat. So that's basically how the four processes or 4 strokes engine is basically works in this situation. This thing can go forever as long as there is that source of heat. So think about this one. This is the Stirling engine. Of course, it's not used in your car. What is used in your car is the Otto cycle or the Otto engine, which we're going to be covering to some detail, at least in the and I think the lab also, and also in the one of the problems probably that we're going to do. Okay, so I guess I can stop the recording now. But before I do that, let me see if I turn off this engine first. Okay. Okay.